Hi, I am Shyamala Gauri, Assistant Professor in Rohini College of Engineering and Technology. Subject code CS3352. Subject name Foundations of Data Science. Unit 4 Python Libraries for Data Wrangling. The topics to be presented here are operating on data and operating on missing data. Operating on data. Pandas inherits much of this functionality from NumPy and the U functions. So Pandas have the ability to perform quick element-wise operations both with basic arithmetic operations such as addition, subtraction, multiplication, etc. and with more sophisticated operations such as trigonometric functions, exponential and logarithmic functions, etc. For unary operations like negation and trigonometric functions, these U functions will preserve index and column labels in the output. For binary operations such as addition and multiplication, pandas will automatically align indices when passing the objects to the U function. Here we are going to see how the universal functions are working in the series and data frames by index preservation and index alignment. First, index preservation. Pandas is designed to work with numpy. Any numpy U function will work on pandas series and data frame objects. We can use all arithmetic and special universal functions as in numpy on pandas. In outputs, the index will be preserved, that is maintained as shown below. For example, x is equal to pd dot series of 1, 2, 3, 4. So the values are 1, 2, 3, 4 and their positions and their indices are corresponding indices are 0, 1, 2 and 3. They are preserved and are maintained. This is shown on the shown in this slide. Pandas will align indices in the process of performing the operation. This is very convenient when you are working with incomplete data. Suppose we are combining two different data sources, then the index will align automatically accordingly. That is, x is equal to pd dot series of 2, 4, 6 and its indices are 1, 3 and 5. For the array for the series y is equal to pd dot series of 1, 3, 5, 7 and their indices are 1, 2, 3, 4. Now if we print x plus y, it prints the results as in the first position there is a value in x and y. So the values in the first position, that is 2 plus 1, is added and it is printed as 3.0. And in the second position there is no value in x and there is a value in y. So for x the value, there is no value, so it prints NaN, that is not a number, and the value in x y is printed as what, 3. And the next position is 3. So in the third position we have values in x and y. The value in x is 6 and the value in x is 4 and the value in y is 5. So 5 plus 4 is 9, so it is printed on the screen. And next position is 3. Next position is 4. Here there is no position, there is no value in the position 4 in x. Only so it is printed as NaN. The value in there is a value in the fourth position in y, so the value is 7. And the last position is 5. For 5 we have a value in x, and for in y we don't have a value, so x will be printed and for y NaN will be printed. Missing data. When there is no data on a specified location, then it is called as a missing data. A number of schemes have been developed to indicate the presence of missing data in a table or data frame. Generally, they revolve around one of two strategies: using a mask that globally indicates missing values, or choosing a sentinel value that indicates a missing entry. In the masking approach, the mask might be an entirely separate Boolean array, or it may involve appropriation of one bit in the data representation to locally indicate the null status of a value. In the sentinel approach, the sentinel value could be some data specific convention, such as indicating a missing integer value with four nines or some rare bit pattern, or it could be a more global convention such as indicating a missing floating point value with nan, that is not a number, a special value which is part of the IEEE floating point specification. The way in which Pandas handles missing values is constrained by its NumPy package, which does not have a built-in notion of NA values for non-floating point data types. NumPy supports 14 basic integer types once you account for available precisions, signness, and Indianness of the encoding. Reserving a specific bit pattern in all available NumPy types would lead to an unwieldy amount of overhead in special casing various operations for various types, likely even requiring a new fork of the NumPy package. Pandas chose to use sentinels for missing data and further chose to use two already existing Python null values, the special floating point nan value and the Python none object. This choice has some side effects as we will see, but in practice ends up being a good compromise in most cases of interest. Operating on null values. There are several useful methods for detecting, removing, and replacing null values in Pandas data structures. They are listed below. Is null of? It generates a Boolean mask indicating missing values. Not null of. It is reverse of is null of. Drop NA. Return filtered version of the data. Fill NA of. Return a copy of the data with missing values filled. Thank you.